In this video, we are finding the length of missing sides in a 90-degree triangle using our trig ratios. Why can't we use the theorem of Pythagoras? I mean, when you see that 90-degree triangle, you're like, oh, let's just use the theorem of Pythagoras. We can't because we were only given one side length. We don't have enough information. And that's where trig comes in so handy. We use our trig ratio to find missing side lengths. Let's have a look. So they gave us that 30-degree angle over there. If we want, we can use sum of angles of a triangle, and then we know that C is going to be 60, so you can position yourself wherever you want. But let's just go position ourselves there by 30. Okay, we do have the hypotenuse. There it is, opposite the 90 degrees. So we've got our hypotenuse. We don't have the adjacent side length. So our adjacent is missing and the opposite is P. That is what we are looking for. We are looking for that one, so we need to bring it into our equation. So we need to go build a ratio with the hypotenuse and the opposite. So which trig ratio are we going to use that uses the opposite and the hypotenuse? Must be sine. So sine 30, because we've got the size of the angle. Sine 30, that's where we are positioned, is equal to, the opposite is my P, and my hypotenuse is 7. There's our equation. Now we just need to solve that. Let's solve this equation correctly. So what I'm going to do, I don't know what you would have done, just as long as you do something mathematically sound, I'm going to multiply this side by 7. Because when I do that, then those two cancel out and I'm left with a P on the right-hand side. But as long as I just also do the same thing on the left-hand side, then I can do that. This is our equation knowledge. So in other words, I am left with 7 times sine 30 to solve for P. And now we're just going to read that into our calculators. 7 times sine 30 is equal to, that gives us 7 over 2. And if we write that as a decimal, we can also write that as 3.5, which is equal to P. And there we go. We've got that the side length for P is equal to 3.5. Now, if you were asked to find side length AB, you could use the theorem of Pythagoras to do it now because we've got a little bit more information. Okay, let's head over to number 2. We've got triangle DEF with a 90-degree triangle. We are looking for a missing side length P. We can't use the theorem of Pythagoras. We don't have enough information. And that is where trig comes in so handy. Let's position ourselves there by angle 25. We could position ourselves by angle D because we able to go find the size of that angle. But yeah, let's not. Okay. Which trig ratio are we going to use? We don't have the hypotenuse. It's P, but that is what we are looking for. So we need to use the hypotenuse because we need to bring it into the mix, into the equation, because we want to solve for that P. If we are positioned there at angle F, then we do have the adjacent, which is 5. So opposite is the missing one. We don't have the opposite side length. So ask yourself, what trig ratio am I going to use where I use the adjacent and the hypotenuse? What is that? It's cos, hey. So cos 25 degrees, we've got the size of that angle. Cos 25 is equal to adjacent, which is 5, over hypotenuse, which is P. And there we've got our equation. I just want to highlight something to you quickly, grade 10s, because I see students mess this up. With the previous example, with number 1, our P was in the numerator of our fraction. And with this one, it is in the denominator. So we just need to make sure that we solve this equation correctly. I know that many of you have a way of, I've heard students and they tell me, oh no, somebody told me I must memorize it like this. And that's perfectly fine. But I just want to show you how we're just solving this equation. It's got an extra step. So I want to get rid of the fraction. So what I'm going to do is I'm just going to multiply the right-hand side by p. And when I do that, they cancel out. So we got rid of the fraction. And then you might think, okay, but we don't want to get rid of the p. Well, we're not, because whatever we do on the one side of an equation, we must just do on the other side as well. So then we are left with 5 on this side. And this side we are left with p times cos 25 degrees. And yes, we are trying to find p. P is our x that we are looking for. So to get p by itself, we are just going to divide both sides by cos 25. See? Because that is how we will get p by itself. And now we're going to put that into our calculators to see what the side length of p is. P is equal to, into my calculator, I'm putting 5 divided by cos 25. And that gives me 5,52. If I round, oopsie, that's not a 5. 5,52 centimeters. That's if I'm rounding it off to 2 decimal places. And there we just found side length P, DF. So now we can use the theorem of Pythagoras to find DE, or we can use trig ratios again. Okay, last example, finding a missing side length. There is our side length that we are looking for. We are inside a 90-degree triangle. Can we use Pythag? Unfortunately not, we don't have enough information. To use the theorem of Pythag, we need 2 side lengths. And that's, again, I said this before, that is why trig comes in so handy. Let's go position ourselves by that angle that we were given and figure out which side lengths we need to use to build our trig ratio. We don't have the hypotenuse. The hypotenuse not given, so we can't bring in a ratio that uses the hypotenuse. Do we have the adjacent? Yes, there's our adjacent side length. It is 4. And then the side length opposite the 50 degree, we also have. That is our P. We need to bring that into the equation, so we need to use that. So what equation are we going to build? Grade 10s that uses that. Must be tan. Tan 50 is where we are positioned. We were given that information, which is equal to opposite over adjacent. Opposite over adjacent. We built our equation, now we just need to solve it. We want P by itself. To get P by itself, we need to get rid of that fraction. We are going to multiply with 4 on this side because then they cancel out, but just as long as we do it on the other side. So that gives us P is equal to, I'm plugging into my calculator 4 times tan 50 degrees. And when I do that, I get 4 times tan 50. And that gives me 4,77 if I round that off to 2 decimal places. And that gives me the side length of that. And now we can use the theorem of Pythagoras to find the length of HI, or we can just use another trig ratio. Okay, and that's it for finding missing side lengths inside right angle triangles using trig ratios.